is Jedediah Heel. I'm a lecture lead for Schulich Ignite 2020. Some of you might know me. I do the Monday lectures. Because of our 2-week break from our last lecture, we decided to do a little review video on the content that we did last time. So we're going to take a look at these if, else if, and else statements again, and the logical expressions we went over last time. So these are the slides from lecture 4. Feel free to look through these first few slides. As a review, we're going to go over these slides in lecture 4. But for now, we're going to take a really in-depth look at this exercise with the ball bouncing back and forth and this screensaver exercise. And then we're going to take it one step further and do the challenge from last time, which was make a Pong game. So let's start out with this first exercise, and we'll see if we can code it, and then we'll try the tougher ones. So I've got my processing open here. As with anything else, you want to start out with def setup. There's setup and draw. You also want to code setup first because it's what gets run first. You don't do much in setup, but you do set your size. I'll set the size of my window to say 1000 by 600, and you want to set your background for the first time. In the example it's black, so I'll just make it black. Okay, next up we have our draw. So what do we want to do in our draw? Well, the first thing we want to do is we want to draw our background every time. We want to draw it first so that we can draw the shapes over top of it. Okay, and then just to test it out, we'll draw a circle at, let's say, 50, 50, 100. And let's see how that looks. Perfect. So now you see, even though I drew it at 50-50, it still looks like it's perfectly in the corner because the circle gets drawn right from the center. So if we drew it at 0, 0, it would be in this top corner here, and we would only see the bottom quarter of it. So if we want the circle to start moving across the screen, we have to change this x coordinate to be a variable. And then we can start that off at 50. And then we need to increment it by 1 each time. Now, some of you might already see the problem with this is that every time I go into draw, I'm resetting x to 50. And then I'm printing it at 50, incrementing it by 1, and then immediately draw gets run again and it gets reset back to 50. So this statement is doing absolutely nothing. What we actually need to do is pop it up here outside of setup and draw and put it as a global variable on its own. There we go. Now we're almost done, but we still don't have access to it yet. We need to access it using global x. Perfect. Now if we try this, we can see it starts to move across the screen. Now it's a little bit slow. If you want it to move faster, you can change this to be a bigger number. Now, as we can see, it just flies off the right side of the screen. So let's see if we can do something about that. First off, we need to identify mathematically the case when it hits the right side of the screen. So obviously we can't just do if it hits the right side of the screen. We have to figure out how to check our variables so that we can tell if it's hit the right side of the screen or not. So the way we can tell is if the x coordinate of the circle is ever greater than or equal to the edge of the screen, which is 1,000. That's the size that we set up here. So 1,000 is the right boundary. If it's ever greater than or equal to 1,000, now what do we want to do here? We could go x minus equals 7, but that would just undo what we did here, and the circle would stop moving. We could go x minus equals 14, but then once it starts moving towards the center, for even one frame, this statement is no longer true, and then it starts moving back towards the right. This doesn't get done anymore. So in here, we need to do something that just occurs once, but causes it to move back towards the left. And the solution is pretty clever. We set up another variable called x speed, set that equal to 7, and then here we just add whatever the x speed is. And we don't care what the x speed is, we're just going to understand that we've set it up to be the correct value somewhere else. So then here, once we hit the right side, all we need to do is set the x speed to be a negative number. We'll do -7 so that it moves back at the same speed that it moves forward at. Okay, now if we take a look at that, it should bounce off the right side. Perfect. Now it is bouncing from the center instead of right from the edge of the circle. So the same reason we start at 50, we're going to end at 950 to account for the circle's radius. Now to bounce it off the left side should be pretty simple. All we need to do is, if x is ever less than or equal to 50, so that's, it hits the left side of the screen, then we can set x speed equal to +7, and it'll start moving back to the right. Now this will work, except because these are related, and I know that these will not happen at the same time, I'm actually going to make this an else-if statement. So that if it goes in and it checks this one, and it's true, it does this one, and then it knows it doesn't need to check this one. So it actually makes the performance a little better, and it's good for organization because you can see that these are related. So let's see how that looks. And we should get it bouncing back and forth infinitely. Perfect. And you could let this run for hours. So that's our first example down. How can we get this second example? So it's actually pretty simple. Essentially, all you need to do is mirror everything you did for x for y, because the x and the y are just running by themselves independently of each other. They're not related to each other at all. So we can sort of use our x as a template for how to do it for y. So we can just sort of copy everything we have for x and just change the names to be y. So let's have it start somewhere in the screen, somewhere a little more interesting. We'll make this start at 400, and we'll make this start at 225. Something like that. Okay, right here, we need to gain access to them. Y and Y speed. Here, we want to print the circle at the Y value, not just constantly at 50. Here, we need to increment Y by Y speed, same as the X. And here, we need to do similar if statements for Y to check if it hits instead of the left and right side of the screen to check if it hits the top and bottom. So I'm actually going to take a shortcut and just copy this. And then I can just replace all of my X's with Y's. Now, these 7s are okay because we said that our speed for both X and Y was going to be 7. Now, this 950 actually needs to be 550, right? 50 less than 600. And this 50 is okay because Y starts at 0, the same as X. Now, if we run this, perfect. It just bounces around the screen and it'll go infinitely. Now, how do we get a Pong game going? Well, if we take a look at our code right now, what we're going to try and do is get a paddle to follow our mouse up and down, and then only have the ball bounce off this side if our paddle is in the way. And if our paddle is not in the way, it should fly past our paddle. Okay? So let's try and get that paddle working. So we're going to draw a rectangle. So the X coordinate, we always want the paddle to be on the left side of the screen. So we're going to draw it at 0 for X. Now for Y, we want to always draw it wherever our mouse is. So you remember mouse X and mouse Y are these variables that processing keeps track of for you. And it just updates this variable with whatever the Y coordinate of your mouse is on that frame. And we're going to set the width. We want our paddle to be pretty thin, say 30. And we want it to be pretty long, so maybe 200. And let's see how this looks. Perfect. So now we have this paddle that follows our mouse. Now I'm going to change this a little bit so that our mouse is in the center, not at the top. So we do that by, because the rectangles are drawn from the corner, we want to subtract 100 from this mouse Y. Subtracting 100 moves it up because Y starts at 0 up here. Okay. Now this is the tricky part, is we want to make some changes to the logic of when it bounces off this left side, because we only want it to bounce off the left side if we are in the way of the ball. So how can we, first of all, which one of these 4 statements deals with bouncing off the left side? So it's actually this one here, right? X is left and right, the left and right sides, and X is less than 50. 50 would be on the left side of the screen. So how do we know if the paddle is in the way? Well, first off, we can add in whatever that check is straight to this statement. Right? If you remember, if we use and or, we can have statements that check multiple variables at one time. Now in this case, we're going to be using and because we don't want one or the other to be true. We want both to be true. But how do we check if the paddle is in the way? Well, the paddle is in the way based on the mouse Y variable. So what we need to do is check and see if the ball's Y coordinate is less than the bottom of the paddle, if it's above the bottom of the paddle, or if it's below the top of the paddle. So how do we check for that? Well, to make sure that it's below the top of the paddle, that means that the Y coordinate has to be greater than or equal to. Now what would the top of the paddle be? top of the paddle would be mouse Y uh, is the center of the paddle, and then to get to the top, as we move up, Y decreases, because Y starts at 0 at the top, so that would be Y minus half of the height of the paddle. And we can do another and. We can do as many ands and ors as we want inside if statements. We want to make sure that the circle is not below the bottom of the paddle. So Y has to be less than or equal to mouse Y plus 100. So let's try this. So let's get in the way for 1, and then let's, awesome, perfect. Now you saw it came in to bounce back a little bit there. That's because it starts moving back and way to the left. Then all of a sudden the paddle is in the way, even though it's not touching the paddle. That's just kind of a bug of the system that you would work out if you were actually making a Pong game. Now, the only problem left is that it bounces off the wall instead of our paddle. That's because we're having it bounce off 50. Because our paddle is 30 pixels thick, we can actually have it bounce off 80. And then it'll look like it's perfectly bouncing off our paddle. Awesome. Now this is pretty cool, but you can actually make it even more fun. You could, for example, if you miss the ball, you could have yourself lose a life, or you can make this into a game against the computer, code a computer to play against you. And if one of you misses, you could restart the game and give somebody a score, different things like that. So keep in mind of things that you want to do for your final project that we can help you with, any games on your phone that you want to recreate, or games online, and make sure you guys are coming to the lectures. All right, thanks for watching. Have a good